Hello students, if you remember in last period we have started a new chapter that is nothing but what? That part is mechanical properties of solid, if you remember. After that we have seen in that case what are the forces acting on a material which are going to change the dimension of material. The first one we have seen a deforming force. Then if you remember we have seen the elastic behavior of the body, and there are two types of body, elastic body and plastic bodies. Then we have seen the two properties also, elasticity, plasticity. Apart from this, we have seen, if you remember, the stress and the strain. Stress is nothing but what? Force divided by area. Force per applied force per unit area, or it's said to be restoring forces per unit area. Restoring forces also we have seen the internal forces created in the material itself. They are said to be restoring forces. Then we have seen the strain. Strain means what? Change in dimension divided by original dimension. Apart from this, there are three type of changes they have discussed in this chapter. That change in length, change in volume, and change in shape of material. Accordingly, there are three type of stresses and three type of strains that already we have learned. The stresses are said to be longitudinal stress, or it is said to be tensile stress. Similarly, longitudinal strain or tensile strain we have seen. The second one we have seen the volume stress, or sometimes said to be hydraulic stress or volume strain. That are the types we have seen. And the last one is nothing but a volume strain and volume stress. That already we have learned, that we have seen. The last one is said to be shearing stress and shearing strain. So these are the three different types of the stresses and the strains according to the three properties: change in length, change in volume, and change in shape of material. Now if you remember, we have already learned the unit of stress. Stress is what? Force divided by area. Its unit is what? Newton per meter square. It is in CMK system or SI system, Newton per meter square. In CGS system, the same unit will be dyne per centimeter square. Then what is the unit of strain? Strain doesn't have a unit. Why? Because it is the ratio of same quantity, change in length divided by original length. Length unit get cancelled out, so it doesn't have a unit. So it is unitless or dimensionless quantity strain is. That much part we have seen. Now let's go to the next one. The next topic of our syllabus, that is nothing but Hooke's law. What exactly this Hooke law is? Hooke law says that within an elastic limit, it is seen that stress is directly proportional to strain, and this law is applicable within elastic limit. What exact elastic limit, that will see later. First of all, the point to remember, Hooke's law says, Hooke is the name of the scientist who has invented this law, so it's said to be Hooke's law. It says that stress is directly proportional to strain. Suppose I have removed the proportionality sign, you can write it like this: stress equal to some constant into strain. We can write it like this. Just remove the proportionality, take equality sign, move the strain to this side. What we get? Stress divided by strain, and is equal to some constant, and this constant of proportionality is said to be modulus of elasticity. It is said to be modulus of elasticity. This constant of proportionality is said to be modulus of elasticity. Now remember, Hooke's law says that within an elastic limit, stress is always directly proportional to strain, and their ratio is a constant. That constant is said to be modulus of elasticity. Now as we know that there are three type of changes we have seen: change in length, change in volume, change in shape. So here's longitudinal stress to longitudinal strain. It is again modulus of elasticity, that is said to be Young's modulus. If it is related to change in length, longitudinal stress would be there, longitudinal strain would be there. Or tensile or longitudinal stress to tensile or longitudinal strain is said to be Young's modulus, which was first found out by scientist Young. That's why the related to length, it is a Young modulus. The second one, volume stress to volume strain, it is again modulus of elasticity, and that is said to be bulk modulus of elasticity. Bulk modulus of elasticity for change in volume. Third one, shearing stress to shearing strain. If there is change in shape of the body, shearing stress and shearing strain would be there. Their ratio is again constant, that is modulus of elasticity. Here shearing stress to shearing strain was represented by modulus of elasticity, that is said to be modulus of rigidity. For length, Young modulus. For volume, it is a bulk modulus, and for shape, it is nothing but what? Modulus of rigidity. These three parts we have to learn further. So before going into detail in the same topic, what they have done, they have seen one graph, they have drawn one graph in your Hooke's law. That graph I am going to draw. It is very simple. Such type of x and y axis they have taken. Along y axis they have taken as a stress. Along x axis they have taken as a strain. Now if you see, this is the Hooke's law, which says that stress is directly proportional to strain. Stress taken along y axis, strain taken along x axis. As they are directly proportional, the line must pass from the origin. It divides this quadrant equally into two pieces. This part and this part must be equal. Then and only then we can say stress is directly proportional to strain. Such type of graph would be there. In your book, the graph they have shown, it is little bit wrong. Why it is wrong? Because they have drawn the graph in y-axis direction. That means in your book they have drawn it like this. Sorry, they have drawn it like this. It should not be like this. In this situation, I have drawn it by blue color line. They are not directly proportional. This black color line, which divide the first quadrant equally into two pieces, then and only then we can say stress is directly proportional to strain. Now the one point is there in Hooke's law, within an elastic limit. Elastic limit means what? If we apply some force to the object and if we remove the force, if the object come to its original place 100%, regain its original place 100%, up to that maximum force we applied, that is said to be elastic limit of the body. If the force applied is greater than that maximum force, then body cannot regain its original shape and size 100%. It becomes plastic now, and that is said to be outside the elastic limit. I hope you didn't understand this. Let's start once again. Suppose we have taken a rubber cord. So this is a rigid support. To this rigid support, I have tied this as rubber. I have just tied this as a rubber. Now when you apply some force to this rubber in downward direction, so this is the weight applied or force equal to mg applied in downward direction. So what will occur? The rubber get elongate. When you remove this force, when you remove this load, what will occur? Rubber again gain its original shape. Suppose this is the original length of the rubber. So after removing this force, rubber come to this position again. Okay, so that is nothing but an extension of the wire. But if maximum force applied to this rubber is this maximum force I have applied, and within this maximum force, when I applied it, wire get elongate like this. When I remove this maximum force, wire come to its original place having a length capital L. But if I have applied the force greater than this maximum force, I have applied, in that case what will occur? This body little bit goes in downward direction further. Rubber get elongate in downward direction because here force applied is greater than maximum force. Now when you remove this force, this rubber, instead of coming to its original dimension here, it may comes here. It never goes here, it comes here. So this much is nothing but what? Plastic behavior created inside the material. Rubber never regains its original shape. This would be the error in the elongation, and that is occur because we have applied the force greater than its maximum value tolerated by that particular rubber. And such a force applied means what? The rubber never come to its original place. It come little bit more than that. Means it behave as a plastic material. It is not elastic now. Now this force F greater than maximum force is said to be outside the elastic limit. Apart from this, if you apply the force less than F max, at any place less than F max, body 100% come to its original shape. Rubber again come to its original shape. But that is the case that we say to be elastic limit. So within an elastic limit, stress and strain are directly proportional to each other. Otherwise, they are not directly proportional. So I think it's sufficient to tell you now today. In detail, we will see in the next. We have subsequent topic. In that topic, we will see exactly what occurred in this case. So I hope that all of you get a Hooke's law. Within an elastic limit, stress is directly proportional to strain, or we can say ratio of stress to strain is always constant within an elastic limit. Now as we have seen, there are three type of things we have learned: change in length, change in volume, and change in shape. Accordingly, there are three modulus of elasticity. The first modulus of elasticity is said to be Young's modulus of elasticity. For that, before going into detail of this, just I will write here Young's modulus. Young's modulus of elasticity. Young's modulus of elasticity. What exactly this Young's modulus? Young's modulus is nothing but related to elongation in the wire or change in length of the wire. So this is the Young modulus related to change in length of the wire. For that, let's draw here one diagram. Just I will draw it here. Suppose this is a rigid support. To this rigid support, I have tied this wire, maybe metal wire, maybe rod, maybe rubber, such type of things. And suppose the original length of this wire from this rigid support to this place, the original length of the wire is capital L. When I applied some force here, what will occur? This get elongate further because of this force applied in downward direction, F equal to mg. This much force is applied in downward direction. That's why this much is the length which get increased in case of wire. Small l I have represented. That is said to be elongation produced in the wire when we apply this force. Just we have seen before this elastic limit like that. So this L is change in length, capital L is original length. And suppose the wire has a radius small r has a radius of wire. Now here we have to find out first longitudinal or tensile stress. First we will find out this longitudinal tensile stress, and that is equal to what? We know that is force per unit area, restoring force or applied force per unit area. And what is the force we have applied? It is mg divided by area of the wire. It is pi r square. R is a radius, so it is pi r square. This is said to be tensile stress or longitudinal stress. Now find out longitudinal or tensile strain. What exactly this is? Change in dimension divided by original dimension. What is change in dimension? Change in length, small l. So we can write this as a small l is a change in length. Original length is capital L here, so it is capital L. So this is said to be longitudinal or tensile strain that we have seen here. Now further, what should we do? Now we have to find out the Young's modulus according to Hooke's law, and that was represented by the capital Y. And this is equal to what? Longitudinal or tensile stress divided by longitudinal or tensile strain. The ratio of stress to the strain, in case of length, it is tensile. So what is the stress? mg divided by pi r square. What is the strain? L divided by L. Put the values, what we can write? Equal to mg divided by pi r square. That is trace I have kept. Now this small l divided by capital L. If we solve it further, if we solve this further, what we get? Here we get this as a mg divided by pi r square. This into small l, capital L goes to numerator, and that is nothing but a Young's modulus of the wire, and this is the formula for that. Mg into original length divided by pi r square into change in length. That will give the Young's modulus of the wire, rod, or suppose we can say elastic type of thing, just like a rubber. So this Young modulus can be found out in this method for this wire. Now what exactly Young modulus is there? So see, if you have the book, in your book there is at the page number 103 left hand side, in a dark color they have just dark black color bold letter, they have shown something that I am going to read. Young modulus of indicate the resistance of elastic solid to elongation or compression. If the value of y is more, I will write somewhere here. If value of y is more, means Young modulus is more, it's quite difficult to elongate that material. The material whose y is more, it's quite difficult to elongate that wire. That is the meaning of that line. And if the y is less, Young modulus is less, you can easily elongate that material. So this Young modulus represent the elastic resistance to elongation. So resistance means what? Opposition to elongation. If y is more, means the material is very strong. it's quite difficult to elongate it. Why is less? Material can easily elongate by applying some force. That will decide the how much wire can be elongated. That can be decided by this factor, and that is said to be Young modulus. Again, its unit is what? Newton per meter square or dyne per centimeter square. And as they have given a dimension, L minus 1, T1 and L minus 1, M1, T minus 2 are the dimension of this thing. This Young's modulus. Okay, I hope that you got this. Now we have to go. Before going to the next topic, in your book there is one table 6.1. They have given some material and they have given the value of Young modulus of some material. The first one, they have taken lead. For lead, the value of Young modulus is 1.5 into 10 raised to 10. 1.5 into 10 raised to 10. The maximum last material they have taken steel, 21 into 10 raised to 10. So from this, which material resist more? Which material resist more or oppose more for elongation? Lead or steel? Definitely it will be steel. Lead is less resistance. Lead apply the less resistance as compared to steel. That's why steel is one of the strongest material they have considered up till now. After that, there are two solve examples in your book. Just try to understand them first. Just read them, try to understand them, and just look at which formula they have used to solve that. Now we go to the next type of modulus of elasticity, that is related to volume, and that is said to be volume bulk modulus. That is nothing but a bulk modulus. So I will write it below here. So it is said to be bulk modulus of elasticity. Bulk modulus of elasticity. What exactly bulk modulus, that we have to learn. Just we have seen before, Young's modulus, change in length. It is related to change in length. Bulk modulus of elasticity, again by Hooke's law we have to find out, and it is said to be change in volume, and it was represented by letter K. It is said to be Young's modulus. Initially that was represented by Young's modulus Y. Now let's start with this. Before starting this, if you remember, in last time we have seen, we have taken one balloon. Suppose this is a balloon with some air, and we have applied some forces on this, constant forces from all six sides. So this is force F, this is F, DF, suppose DF, DF, and this is DF. These are the four forces from the top, and from the bottom again DF force get applied. When you apply equal forces from six sides, what will occur? The volume of the balloon get decreased. Volume get decreased, and that decrease in volume is suppose dV. Change in volume is suppose dV. Now here again, just we have to find out first volume stress, then volume strain, then take the ratio, you get a bulk modulus. So let's start with here first. First of all, what we have to find out? Volume stress. So find out volume stress is equal to what? Force applied on this divided by area. Force divided by area. If you remember, when we have learned the first chapter, that is nothing but fundamental quantities, the unit and measurement, if you see. The force divided by area is a pressure, and here the force applied is what? dF on area A, suppose, and so this will give us a pressure dP. This will give us a pressure dP. Just see the first chapter, there is one table for fundamental quantity, derived quantity, there is one term pressure. Pressure equal to force divided by area. So this we have find out longitudinal stress. Now volume stress. Now find out volume strain. Now we know volume strain means what? Change in dimension divided by original dimension. What dimensions we have changed? Volume we have changed. So the change in volume is dV. Original volume is, suppose it is V. So dV by V. Now we have the we have the volume stress as well as we have the volume strain. Now take the ratio, we get a bulk modulus of elasticity K. So the bulk modulus of elasticity K is what? Volume stress divided by volume strain. Now what is the volume stress? It is change in pressure. It is represented by dP divided by this volume strain is what? Change in volume divided by original volume. Before going into further, there must be minus sign. That already we have learned. Why so? Because as forces increases, volume decreases. So this volume is decreasing. That's why the minus sign. So suppose I have not taken minus sign here. Just you can write this magnitude we have taken. It is dV by V. dV by V. Such type of thing we can write here for this. Now volume related to volume, we can write this dV by V. Now if you solve it further, just put this value dP divided by dV by V. What we can write? It is equal to V goes to numerator, V into dP divided by dV. That is nothing but a bulk modulus represented by K. So this is a formula for bulk modulus of elasticity that we have find out for a change in volume. Again, this we have find out according to this formula is for what? This is Hooke's law, and that we have find out. Now see, again, just similar to first one, again there is one table 6.2. They have given the bulk modulus of some well-known material, just like a lead and gold would be last now. So they have just given the value of bulk modulus. Just go to that. Apart from this, in your book, again they have mentioned one thing. The units are definitely same, Newton per meter square or dyne per centimeter square. Dimensions are same. What is the point to remember? Just they have explained another quantity from this, that is said to be compressibility. The reciprocal of this bulk modulus, gives the compressibility. How can we find it out? Just look at here. So if I take 1 divided by K, and that is said to be C for compressibility. So compressibility equal to reciprocal of bulk modulus. So we can write this equal to what? 1 by V dV by dP. Exactly opposite of this, reciprocal of this. 1 by V dV by dP. So what should be the unit of this compressibility? This has a unit Newton per meter square. This has a unit meter per Newton. That's it. That is the only difference. And so we have mentioned here the new quantity. Dimensions get reversed. What are the negative signs in this bulk modulus dimension? They becomes positive. The positive becomes negative because we have taken reciprocal. So this is nothing but said to be the bulk modulus of elasticity. So this change in volume. Now the last one we go, that is said to be change in a volume. Change in a volume means what? We should consider the modulus of rigidity. Now we have to consider the third type of modulus of elasticity, and that is said to be modulus of rigidity. So I will write here modulus of rigidity. This modulus of rigidity represented by the symbol like this, and that is not n, it is said to be eta. That is not n, it is said to be eta. Now this modulus of rigidity is a third type of modulus which depends on change in shape of the body. So here in your book they have drawn such type of thing. Just I will try to draw it. Such type of thing they have tried to draw it. They have drawn in your book. So we will draw accordingly. So such type of diagram they have drawn. Okay, such type of cube they have taken. Now you can do it by two methods to find this. Actually, one method is what? Either just fix the bottom part of the cube on the table, stuck it to the table, apply the tangential force at the top that we have learned in last video. What we have done, this part, just suppose this cube was kept on a table and this bottom part that I have shaded it here like this, that part is stuck to the table on which the cube is kept. That is the first way. Stuck it at the bottom. Now apply the tangential forces from this side here at the top. If we apply the tangential forces F, then definitely what will occur? There is change in shape. How the shape gets changed? Initially it is like this. Now it becomes tilted. Means what? There is change in shape like this. This place goes somewhere here. This place goes somewhere here like this. You can draw. So this is the first point. We go. This is the angle theta. We can write it like this, theta. And here, similar to this place gets shifted backward little bit like this. This goes here like this. Then we can elongate it further and you can connect them further like this. Such type of shifting, block gets shifted to that side. Okay, that can be occurred when we apply such forces. And then here, if we consider this as theta, and this is the length of one length, or we can say height of the whole cube L, and this is a this much is a change in the length. Suppose it is L, delta L, you can say that is change in length, that is suppose delta L they have taken in your book, we will take delta L. Then here what we can make, we can just find out longitudinal stress and longitudinal strain by this method. This is the first method I have told you in first video. But in your book, in this, what they have mentioned, they told us that we have not fixed the bottom. We have not fixed the bottom. We have applied two forces in opposite direction. If you apply the force at the top from left to right, just apply the same amount of force from right side to left side on the bottom. So this at the top, this at the bottom. This is at the top, this at the bottom. Due to this, cube get displaced like this. Just initially cube is like this, and due to here we are applying force, here we are applying force. So it goes like this. So there is change in shape. Again there is change in shape. Same diagram we get. Only difference is what? Here the force F, here exactly opposite force we have applied, and they will form a pair of forces that are said to be couple. Whenever two forces acting at two different points on same body with the same magnitude, the two forces are said to be pair of forces, and they are said to be forming couple. Now let's go according to the Hooke's law. Just we have find out first shearing stress. We are going to find out shearing stress. It is what? Force applied per unit area. The force applied, tangential forces applied per unit area. Now what is shearing strain? Now just similar to this, find out a shearing strain. What is the shearing strain? It is what? Lateral displacement of layer delta L divided by original length of the layer, that is L. So you can write this as a delta L divided by L. If we take tan of theta, opposite side, it comes to be delta L divided by adjacent side, it is L. So this is equal to tan theta. This is equal to tan theta. And if theta is very small, this is nearly equal to theta. If theta is very small, then you can write it nearly equal to theta. Now just apply the Hooke's law. So what is eta equal to? Modulus of rigidity, eta, change in shape, is equal to what? Shearing stress divided by shearing strain. What is he mean by shearing stress? F divided by A. So F divided by A divided by shearing strain is equal to theta. So you can write like this. If we solve it further, what we get? You get here F divided by A into theta. So this eta equal to F divided by A into theta. That is said to be modulus of rigidity. That is said to be modulus of rigidity. Now see, again they have taken table here. Some material they have given, and below that they have written the bold letter, that is rigidity modulus indicate resistance offered by the solid to change in its shape. Resistance, opposition to change in shape. How much this body opposes to make the change in shape, that will decide the modulus of rigidity. Similarly, just we forget to tell you, for a bulk modulus, just if you go to page number 104, right hand side below the table, same thing they have mentioned. Bulk modulus measured the resistance offered by solid, liquid or gases while attempts are made to change their volume. While changing the volume, how much they will resist? Resist means oppose. That is nothing but a bulk modulus. In Young modulus, resistance to elongation. Bulk modulus, resistance to change in volume. And here modulus of rigidity, resistance to change in a shape of the body. So in this fashion, we have learned these three things. So we have seen Hooke's law, we have seen the modulus, different modulus of elasticity, that is nothing but what? We have seen the Young's modulus related to length, then we have seen the bulk modulus related to volume, then we have seen the modulus of rigidity related to change in shape. So these are three modulus of elasticity that we have learned according to three types of stress and strain, and we have seen this all modulus. Now just do one thing. I'm forget to give you homework extra day. The homework to all of you, you have to just find out difference between elasticity, elasticity and plasticity. Just try to find out the differences. At least four differences you should find. You have to find out the four differences between elasticity and plasticity. You can give the examples, you can give the definitions. Internal forces are, see what are the first definition of elasticity. It will regain its original shape and size 100%. It can't regain its original shape and size. Second, internal forces are produced in elastic bodies. The internal forces are absent in plastic bodies. Okay, that's why this is elastic now. Third one, what you can mention, third one you can use here, what examples. Example of elastic bodies or rubber, cords, that we can explain. Plasticity, mud, putty, clay, these are the examples. Fourth one, elastic body obeys the Hooke's law, and this plastic body or plasticity never obey the Hooke's law. So these are the four distinguished. Just take one blank paper, write all these four differences, and just put this in here to this topic in your book. Okay, so this will be the first homework of last video. Now today's homework I would like to give you, just make a 3 columns and try to find out difference between young modulus Y, bulk modulus of elasticity K, and modulus of rigidity eta. So just take a one paper, make it 3 column, again find out the four differences: young modulus, bulk modulus, modulus of rigidity, and fourth one is nothing but what? Same, four differences. First definition: young modulus related to length, related to volume, related to change in shape. Okay, that's first we have find out. Formula: y equal to mgl divided by pi r square. L, k equal to, we can write v into dp by dv, and here eta you can write down that a divided by, sorry, f divided by a theta. Third, this young modulus is property of solid only because solid has a length. Volume: solid, liquid, gas all have a length. The volume, so this is property of all. The shape: solid has a shape, so this is a property of solids only. Fourth one you have to try to find out. Fourth one you have to try to find out. I'm not going to tell you what are difference. Fourth, that this homework to all of you, you have to find out the four difference for this. So let's go further. I think it is better to stop here. In next period we start with the next topic, that is nothing but what? Poisson's ratio. They have given here Poisson's ratio. That topic will start, it is better to start in a next period. Okay, so just try to view the video, try to understand it. Once you watch the video, then go to the same topic from your book and read the same topic. Then and only then you get better understanding. So just remember, watch the video two times, at least two times. If it is better, you can watch it one time only, but for some student it is essential to watch it two times. So watch it two times, then read the same from your book, then your understanding get improved. Okay, so take care, and just we'll see tomorrow or day after tomorrow for a next video lecture. Thank you.